would look like 3, -6, 9, 2, 1, -4. Let's go through this quickly. I would turn the top left to 1. So I'd multiply everything in the first row by 1/3. Becomes my new row 1. And so my new row 1 is going to look like 3 divided by 3 is 1. Then we'd have -2. Then we'd have 3. Bottom row wouldn't have changed. I have 2, 1, -4. The next thing I need to do is turn that 2 into a 0. So I'm going to multiply row 1 by a -1 and add it to row 2, which will become my new row 2. So then I'm going to have, first row stays the same, 1, -2, 3, -1 times 1. Ooh, I'm sorry. Moving way too fast. I should have multiplied row 1 by a -2. Because -2 times 1 plus 2 would give me a 0. -2 times a -2 is 4, plus 1 is 5. And -2 times 3 is a -6, plus a -4 would be a -10. All right, then I need to find the 1 in my next column. That's that 5 there. So I'm going to divide everything in row 2, or multiply everything in row 2 by 1/5 to become my new row 2. That is going to give me 1, -2, 3 on top. Still 0. We'll have 1. -10 times 1/5 is going to be a -2. So that means my y is a -2. So in fact, I actually know the answer. It's got to be B. Let's hope it actually turns into that -1. All right, to get rid of that 2, because that needs to become a 0, I'm going to multiply row 2 by 2. I'm going to add it to row 1. That's going to become my new row 1. And we're going to end up with a small squish thing, but we're going to have 1, 0. 1 times -2 is -2, plus 3 is... Oh, I'm sorry, -2 times 2 is a -4, plus 3 is a -1. And then we have 0, 1, -2. So our and answer is x equals a -1, y equals a -2. But that only was resulted because I lined up my variables. And that's what several of you got wrong on the homework, particularly number 8 and number 9. Number 8, you had x plus y equals 4, and y minus 2x equals 13. You should have changed it to being x plus y equals 4 and -2x plus y equals 13. Number 12, you should have reorganized the stuff to be 5x minus y equals 2, and that would line up with 10x minus 2y equals 12, which, if you plugged in your calculator, would have been inconsistent. So that's why some of you might not have lined up with the answer key. That being said, do we have any questions on the homework? Brian? Yeah. So like I said, your number 12 started out looking like 5x plus 2 equals y and 10x minus 2y equals 12. You would have had to rewritten it as 5x minus y equals a -2, and we would have left this as 10x minus 2y equals 12. So then in your calculator, that's not enough erasing. In your calculator, you would have typed in the matrix 5, -1, -2, 10, -2, 12. And I forgot exactly what your calculator spits out, but it spits out something that has like the bottom row is like 0, 0, and maybe it's a 1 here, letting you know that 0 equals 1, so it's a false statement, so it's inconsistent. So you're looking out for that 0, 0, 1 for inconsistent. If it would say 0, 0, 0, it would be dependent. Anything else would be independent. Other questions? Okay, then we'll go over to today's lesson. Today's lesson is on adding and subtracting matrices. Well, that's what we're going to start off with. So when you are adding or subtracting matrices, you have to make sure the size of both of your matrices are the exact same size. You cannot add or subtract unless you have the exact same size matrices. And then you just add the corresponding entries. Once again, this is the big thing, because on the test, if I say add these two things together and you can't, just put you can't add those together, and then you're done with that problem, versus trying to do it all and making mistakes and getting 0 points on it. So always check to make sure they're the same size first. So we look at A equals the matrix that is a 2 by 2. The other one is a 2 by 2, so they are in fact the same size. So that's the same size as this one. They're both 2 by 2. So I can add them. Now we're just going to go element by element. So when we're adding these two things together, I guess I'll go step by step. So we have, currently we're trying to do -4, 3, 5, -2. And I'm trying to add that to 7, -3, 2, and -5. Like I said, you add element by element. So if we look at that 4 right here, we're going to add that to that 7, top left to top left. So our new matrix is going to look something like this. I'm going to go -4 plus 7. Then I'm going to look at that 5. That 5 I'm going to add to the 2. So in that bottom left, I'm going to have 5 plus 2. Then we look at that top left, that 3, or top right, I should say, and we're going to add that to that -3. So we're going to have 3 plus a -3 in our top right. And finally, in our bottom right, we have that -2, which I'm going to add to that -5. So we're going to have -2 plus a -5. And then we're just going to do the addition. We're going to go -4 plus 7 is going to equal 3. 3 plus a -3 is 0. 5 plus 7 is, or 5 plus 2 is 7. -2 plus a -5 is a -7. And now I just added those two matrices. So if I have a 2 by 2 and I add it to a 2 by 2, it's going to equal a 2 by 2. All you're doing is adding all of the elements. Let's switch this one up. I don't know why I did 2 additions on there. Let's go ahead and do subtraction on this one. Let's make it to a minus b. If I use a minus b, it's going to be the exact same steps. But now we're going to throw a subtraction in there. So in our next one, we are going to have 3 minus 5. In the bottom left, we're going to have a -1 minus 1. And then we're going to go ahead and do a -4. Not a -4, I'm sorry. A 4 minus a -4. In the bottom right, we're going to do that 5 minus 4. So just to be clear, if I'm doing a minus b, always make sure your a come first and your b's go second. That's just going to equal 3 minus 5 is a -2. -1 minus 1 is a -2. 4 minus a -4 is actually 4 plus 4, so that would be an 8. And finally, we have 5 minus 4, which is just going to become a 1. So that is adding and subtracting matrices. Down below is more or less how a test is going to look. I'm going to give you a whole bunch of matrices, and I'm going to say, go A plus B, B plus C. And we'll talk about on Monday how to multiply them. So just get used to being able to see a whole bunch of matrices and thinking about whether you can do it and how you do it. So this one says do A minus B. So we're going to take A and B. And the first thing I'm going to do is I'm going to make sure they're the same size. If they're the same size, you are allowed to subtract them. Well, A is a 1 by 3. B is a 1 by 3, so they're the same size, so you can subtract them. So they're the same size, so that means you can actually do the math. So we're going to do A minus B, so that means every element in A, so we're going to take 3 and subtract that same spot on B, so that is minus 3 for my first element. My next element is going to be the element from A, which is 5, minus the element from B, which is a negative 1. So we're going to have 5 minus a negative 1. And finally, we're going to go to that far right one and do 8 minus the element from B, which is 6. So A minus B is just going to equal 3 minus 3 is 0. 5 minus a negative 1 is 6. 8 minus 6 is going to be 2. Same thing for C minus D. I'm going to make sure they're the exact same size. That's the only way you can add or subtract. So C has 3 rows, 1 column, so that's 3 by 1. D is 3 rows, 1 column, so that is a 3 by 1. They're both 3 by 1, so they are in fact the same size. So we can do the math. Once again, we're going to pull from C first. C is that negative 3 on top. And I am subtracting away D, so I'm going to subtract 4. My next row is a 5. Subtract away the next row in D, which is a 7. And finally, we have 6 minus 2. And so that's going to equal a negative 7. 5 minus 2 is or 5 minus 7 is a negative 2. And 6 minus 2 is 4. Our next one is A minus C. Well, A is a 1 by 3. D is a 3 by 1. They seem like they're the same size because they're using 3s and 1s, but they are different sizes. They are not the same size, so you don't have to do it. Not the same size, so you can't add or subtract. Now, Monday we're going to talk about multiplying. Multiplying doesn't follow the same rule. You're still looking at sizes, but they don't have to be exactly the same size. This is just for adding and subtracting. They have to be the exact same size to do it. All right, so that's adding and subtracting. The next thing we're going to move on to is something called the additive inverse. The additive inverse is basically, when we're talking about additive inverses, if I have 2 and I ask for your additive inverse, you say it's negative 2. Because 2 plus a negative 2 equals 0. That's what it means to be an additive inverse, that it ends up being 0. So for example, the same logic is going to apply for matrices. I want to find a matrix that when I add it to my original matrix, comes up with what's called the 0 matrix, all zeros across. Well, when we're adding and subtracting, we're adding element by element. So if I want to create an opposite or an additive inverse of a specific matrix, I'm just going to find that opposite or additive inverse of each element. So every element I'm going to find the additive inverse of. So in this case, our additive inverse, which is we put as a negative A, is going to equal the additive inverse of every single element. So the additive inverse of negative 1 is just a positive 1. Additive inverse of a 2 is a negative 2. Additive inverse of 0 is still 0. Come down, 4 will become a negative 4. Then we'll have a positive 3. Then we'll have a negative 5, a negative 2, a 0, and a positive 9. So the additive inverse is basically multiplying your entire matrix by a negative 1. Every element's being multiplied by a negative 1. Because our end goal is, if I add A to negative A, we should result in a 0 matrix. That's what it means to be an additive inverse. So what that would look like is A plus negative A is going to equal, if I go element by element, negative 1 plus 1 is 0. So if I added these two things together, I would end up with a 0 up there. The next spot would be 2 minus 2, which is 0. 0 minus 0, which is 0. 4 plus a negative 4 is 0. And continuing on, you're going to come up with all zeros. And once again, that has a specific name that is called your zero matrix. But if you understand how to add or subtract matrices, it shouldn't be that hard to come up with your additive inverse. Additive inverse is always what equals 0. And you're just going to do it for every element so that you can come up with the zero matrix. All right, the last thing we're going to talk about is just a scalar multiplication. Remember, a scalar multiplication when we dealt with vectors just made a vector longer. Well, a scalar multiplication on a matrix basically either makes every element bigger, smaller, or negative at the same exact rate. So, when you're doing scalar multiplication, you are just going to multiply every single element by that scalar factor. That way, every element is being affected equally. So if I'm doing 3 times A, that's going to look something like 3 times, and you'll put it right in front of your matrix, negative 2, 3, 5. Well, you're just going to multiply every single element by 3. So we're going to have 3 times a negative 2. We're going to have 3 times a 3. And finally, we're going to have 3 times 5, which is just going to equal a negative 6, 9, and 15. So that scalar factor went to every single element and stretched it by 3. Well, that's how it works if it's a 1 by 3, but it's going to work the same thing as if I had a 2 by 2 or a 3 by 3 or a 6 by 2 or whatever size you have. So in this next case, we'll have negative 2 times negative 3, 4, 2, and negative 6. Well, that's just going to equal me distributing it, basically, or scaling each one of those elements by a negative 2. So in the top left, I would have a negative 2 times a negative 3. Top right, I'm going to have a negative 2 times a 4. Bottom left, I'll have negative 2 times a 2. And finally, I'll have a negative 2 times a negative 6. That's going to end up equaling, well, negative 2 times a negative 3 is a positive 6. Negative 2 times 4 is a negative 8. Negative 2 times 2 is a negative 4. Finally, negative 2 times a negative 6 is a positive 12. Final one is just distributing a negative 1. That's the same thing as creating an additive inverse. So if I multiply an entire matrix by negative 1, I'm just switching all of the signs. So basically I'm looking at negative A, which is just going to equal 2, negative 3, negative 5. Any questions on any one of those? All right. It's pretty easy stuff, multiplying by a scalar factor and adding. Basically, you don't have to do much to the matrix. They're not going to change sizes. They're going to stay the same. It's distributing and matching up elements. On Monday, it's going to be a little more complex because we're going to start talking about multiplying actual matrices, and then we'll talk about how to use inverses. All right, right below this, there should be a problem that says review on it. Am I right? Mine doesn't, but I believe I put it on. That's just practice. All right, it's another Gaussian elimination practice problem. So go ahead and do that as part of your homework and the rest of the homework. Really quick, look at 1 and 3. 1 and 3 I didn't directly teach in this lesson. But think about this. Matrices occupy a space. So if you look at the first one, we have a matrix that is a 2 by 1, and the other side is a 2 by 1. If I say x over 5 is my matrix, and the other side is a 2 over y, the space that top element occupies will be the same space as the top element on the other one. In other words, what I'm actually saying in that one is x equals 2 and 5 equals y. All right, what's on the left-hand side needs to match up with the right-hand side for them to be equal. Like if I had a 3 by 3 equaling a 3 by 3, that top left has to equal the top left on the other side. The top middle would have to equal that top middle on the other side because nothing's happening. Nothing's being added or subtracting. So use that fact to answer 1 and 3. And the rest is up to you. All right, rest of the time is yours. You should make a really good start on this, if not getting done.